Okay, welcome back. So in the last videos we talked as to how the motion of an object changes under translational motion, and also in the last series of videos on mechanics I talked about the motion of an object traveling under gravity, or the motion of an object under gravity. So the simple scenario is you throw an object at some velocity about say 20 meters per second, and then it goes up. So the maximum velocity is at the point of projection, and the minimum velocity, which is 0, is at the point of maximum height. So it reaches the maximum height and comes back and gets the same velocity at the position of projection. So I talked about translation motion in a single plane. So for example, take a car moving on a road from city A to city B. So that's translational motion. The car moves at some velocity, say 20 meters per second. So that moves in the simple translation motion like this. So taking this the axis as the taking this as the bar, I'll take the object like this. So if I give some force F, this moves with velocity 20 meters per second and comes here at some time. So you know that if the velocity is the same here at 20 meters per second, right? So you know this is the motion in horizontal mode. This is the horizontal motion. So the object moves from here to here in a horizontal way, from here to here in a horizontal way. Now the same object, if it is moving on a vertical plane like this, if the object is on a vertical plane like this, if it has velocity say 50 meters per second, and goes up to this point like this and comes back here, it moves in a vertical path. So it is a vertical motion. So this is a horizontal motion and this is a vertical motion. So as far as you know, I have taught you about this horizontal motion and vertical motion in other videos. So if you are not well versed with this subject, I invite you to go to watch those videos and come back here, because the motion of horizontal videos and vertical videos, horizontal motion of motion of the particles in horizontal motion, and the motion of particles in vertical motion and horizontal motion are very important to understand the concepts that I will be teaching you today. Alright, so I have been teaching you about the vertical motion and the horizontal motion. Now what happens if an object is projected at an angle? Now you have considered that if an object is moving on a horizontal plane, it is moving parallel to the plane, and if an object is moving vertically, it is moving perpendicular to the plane. Now you have considered an object's motion in a parallel path that is parallel to the path of the plane, and the motion of an object that is perpendicular. Now all the objects, all the motions in the world are not perpendicular or parallel to some plane. So if you project an angle, say if you are playing soccer, or if you are playing cricket or baseball or some sport like that, you need to project at an angle. Now if you are in soccer, you can't hit the ball, you can kick the ball with that horizontal velocity, you can kick the ball with a vertical velocity. If we are making it only a vertical velocity with the horizontal component 0, it will go in a vertical direction, but it will come back to you. So that's meaningless. And if you are playing in a horizontal direction, it will have a direction in that motion. So that will not be an advantageous for you as well. So you can't use only the horizontal velocities and the vertical velocities when you are studying about the motion of objects in a single plane. So you need to understand what happens if an object is moved that is angled to the plane. Now I'll take a horizontal plane, so you can consider this as both an inclined plane and a horizontal plane. So inclined planes are somewhat complicated in the study of this type of angle motion. So first of all, for the first few videos, I'll be only using the concepts on horizontal track or horizontal path, and then I'll be talking about the motion on an inclined plane. Alright. So what happens actually? So for the example I took, what happens if I kick the ball with some velocity 20 meters per second, that is about say 30 degrees angle to the horizontal. Now if you have some velocity like that, now if I draw that, we have velocity like that. Now if I have some velocity in this direction, say this velocity is 10 meters per second, and that is angle to the horizontal at 30 degrees. So this is angle to the horizontal at 30 degrees. So this will be 30. Alright, this will be 30. So what actually happens is that this object has some, now you know about now this velocity is a vector. Now you know about the decomposition of vectors in the horizontal and vertical directions. Now what you can do here is actually you can decompose this velocity in the vertical and the horizontal directions. Now you can consider this motion and you can decompose this velocity in the vertical and the horizontal directions. So what I'll do, if this velocity is 10 meters per second and this angle is 30, I can take this one as 10 cos 30 meters per second and this angle as 10 sin 30 meters per second. So that's very simple. 10 cos 30 meters per second and 10 sin 30 meters per second. So that's very simple. So now if I consider this part, I have a horizontal motion in this direction. Now if I have a plane like this, if I have an extended plane like that, I have some horizontal velocity. So if I have some horizontal velocity, I should have some horizontal acceleration as well, because the object is initially at rest. So to gain some velocity, I should provide some force. There should be some force at which I am projecting this motion. So there's some force, so there's some velocity, so the object moves in this direction. So it has 10 cos 30 meters per second in that direction, so the object moves in the horizontal direction. Similarly, this has 10 sin 30 or 5 meters per second in this direction, so the object moves in the vertical direction as well. So what happens when an object moves both in the horizontal and vertical directions? Now if you consider the object's motion, now if you put this, if you take the object's motion in this two coordinate plane for some axis, now you can say I'll take some point A here. Alright, I'll take some point A here and I'll take another point B. So I'll consider only the motion between these 2 points, A and B. Alright. Now if I project this a particle from A so that it goes to B in both the horizontal and vertical direction, what will happen to its path? Alright. So if I have some velocity here, so 10 meters per second,